Today I'm going to talk about the superposition theorem. The first thing is we shouldn't get confused with the superposition of quantum superposition in quantum physics or law of superposition in geology and archaeology, and so on. This is the superposition theorem in electrical engineering. In one electrical circuit, we may have more than one source in the circuit. It could be two or more voltage sources, or more than one current source. In other case, we can have both voltage sources and current sources in a circuit. The theorem is applicable when the network is linear, and it states that the voltage across or the current through a component in the circuit is equal to the algebraic sum of the voltages or currents produced separately by each source. Here are steps to apply superposition theorem in practice. First is to replace the independent sources, if they are voltage sources, and replace them with a short circuit. Otherwise, if they are current sources, replace them with the open circuits. Next, we're going to calculate the voltage or current of the components with each source. Just remember that the number of the sources in the number of the values you get. And lastly, find the sum of all the results that you have calculated before. Note that defining the polarities of voltage across or the direction of the current through the components before summing up. Let's have a look at an example. We have a circuit which includes two voltage sources. One is 28 volts, the other one is 7 volts. There are three resistors placed as in the graph. The question is to find the current through R2. Apply the superposition theorem to this example. There are two sources, it means that we have to calculate the current through R2 two times. In case 1, we use the 28 volt source and get rid of the 7 volt source. Assume the direction of current in the circuit is as shown in the graph. Then we find total resistance and source currents by Ohm's law. As in the Kirchhoff current law, the input current goes into one node must be equal to the output current. That's why we have I2 plus I3 equals to I1, the total current. Use current divider rule to find I2. I2 is equal to total current times with the value of R3 on the sum of R2 and R3. The produced result is at 2 amps. In case 2, we will get rid of 28 volt source and use the 7 volts one instead. The rules of calculation is the same as in case 1. This will give us the result of I2, which is 2 amps. So in total, the current through resistor 2 is the sum of the results from case 1 and case 2, which is 4 amps. That's the end of the video. Thank you for watching, and if you like this video, please press like and subscribe to my channel. Away, and good luck with